What kind of flower is this? You might recognize it as a rose, for its luscious red petals, or its refreshing scent, or even the time you got pricked as a kid. But if you ask a neuroscientist, they might say that your memory of a rose is actually encoded in the connections between tiny cells in your brain. And building a map of all of these connections across your entire brain could lead to breakthroughs in neuroscience, drug discovery, and disease diagnosis.
Your brain is a little like this hyper-efficient megacity. There are billions of tiny cells called neurons that talk to each other by making thousands of connections to other neurons. This network of almost 100 trillion connections lets you think, play, work, see. It's what makes you exist. This network of connections is called the connectome, and mapping the connectome is one of the greatest technological challenges of all time. It's believed that specific memories may be represented as the connections between neurons. These connections could represent a sequence of a time-based memory, like brushing your teeth, and these might represent how to ride a bike. With a connectome, neuroscientists may be able to follow chains of neurons to read out your memories. And if they can read out memories, they might even be able to read out your personality or you entirely, just from your connectome. But we'll have to map a connectome for both types of connections in the brain. Structural connections, like a neuron that talks to its immediate neighbor, and functional connections, like neurons that work together but don't touch. Using advanced artificial intelligence algorithms, scientists are mapping a cubic millimeter of a mouse's brain. Even though it's the size of a grain of sand, that cubic millimeter contains over 2 million gigabytes of data. The cubic millimeter is chopped into cubes that are a billionth of the size of the original cubic millimeter. Slices of these pieces are given to the algorithm, which colors in individual neurons, slice after slice after slice from the top, to reconstruct the 3D shape of small fragments of branches of neurons. This process is repeated for all the neurons in the cube. Using this method, we can finally see individual connections and the neurons that make those connections. Although artificial intelligence algorithms significantly speed up the process for labeling neurons, mapping a connectome, even a partial one, of a cubic millimeter of a mouse's brain will take a very long time. What's more, these algorithms aren't perfect, which means that humans have to go in and proofread the work of these algorithms anyways. That's why neuroscientists are calling for gamers and citizen scientists like you and me to help map connectome. Over 250,000 gamers and citizen scientists have come together on iWire to reconstruct intricate three-dimensional neurons in a mouse's eye.
Someday, when researchers and citizen scientists like you and I map every single neuron and every connection in our brains, we'll be able to unlock the secrets of the most complex machine known to humanity, our own mind. Thanks for watching.